On August 15, 1977, something extraordinary happened. Deep in the constellation Sagittarius, a radio telescope in Ohio picked up a signal from space. It lasted exactly 72 seconds. 3 days later, astronomer Jerry Amon was reviewing the computer printouts when he saw it. A sequence of letters and numbers that made his heart race, 6EQUJ5. Without thinking, he grabbed a red pen and circled the data. Then he wrote a single word that would echo through history. Wow! Nearly 50 years later, that signal has never been heard again. Was it interference? A natural phenomenon we don't understand yet? Or was it something else entirely? Today we're diving into one of science's most tantalizing mysteries, a 72-second burst that could change everything we know about our place in the universe. Picture this. It's 1977. Star Wars just hit theaters. The world's buzzing about space, but in a quiet field in Delaware, Ohio, something much more significant was happening. Meet Big Ear. Not your typical radio telescope, this massive structure covered an area larger than 3 football fields. It was the brainchild of Dr. John Krauss, who designed something that looked more like a futuristic sports arena than a scientific instrument. The design was brilliant. A flat reflector, 340 feet long, directed radio waves to a parabolic reflector. From there, signals traveled to 2 horn antennas positioned 410 feet away. It was equivalent to a circular dish 175 feet in diameter. But here's what made Big Ear special. After completing sky surveys in the early 70s, Big Ear became the world's first full-time SETI program. SETI, the search for extraterrestrial intelligence. For 22 years, this telescope would listen to the cosmos, hoping to catch a whisper from another world. The team was small, underfunded, mostly volunteers who believed in something extraordinary. Jerry Amon was one of them, an astronomer who spent his free time combing through endless computer printouts. Because here's the thing about 1970s technology. There was no real-time analysis, no instant alerts, just stacks of paper covered in numbers and letters, waiting for human eyes to spot something unusual. Most of the time it was just noise, the cosmic static of a universe that seemed disappointingly quiet. But on August 15, 1977, that changed. At exactly 10:16 p.m. Eastern Time, Big Ear's computers recorded something they'd never seen before. The signal started weak, grew stronger as the telescope's beam centered on it, then faded away. Just like you'd expect from something actually out there in space. The intensity was unlike anything they'd detected, 30 times stronger than background noise. And it lasted exactly 72 seconds, the full duration Big Ear could observe any point in the sky before Earth's rotation carried it away. 3 days later, Jerry Amon made the discovery that would define his life. Imagine you're Jerry Amon. It's a quiet morning in Columbus, Ohio. You're at your kitchen table with a cup of coffee and another stack of printouts, page after page of cosmic static. Then you see it. 6EQUJ5. Those characters weren't random. They represented signal intensity over time using Big Ear's measurement system. Numbers 1 through 9 showed standard signal strength. But letters meant something big. And that represented an intensity of 30 times stronger than the background noise of space. Without thinking, I wrote, "Wow," Amon later recalled. It was the most significant thing we had seen. But the signal's intensity wasn't the only remarkable thing. Its frequency was extraordinary too. The WOW signal was detected at 1420.4556 MHz. Why does that matter? Because it's incredibly close to 1420.4058 MHz, the frequency of neutral hydrogen. Hydrogen is the most abundant element in the universe. In 1959, 2 physicists named Philip Morrison and Giuseppe Cocconi had a brilliant insight. If alien civilizations wanted to communicate, they might use this universal frequency, a frequency that every scientifically advanced species would know about. And here's the kicker. This frequency is protected by international agreement. No terrestrial radio transmissions are allowed in this band. So interference from Earth-based sources was extremely unlikely. The slight frequency offset suggested whatever was transmitting might be moving toward Earth at about 10 kilometers per second. The Doppler effect in action. But perhaps most intriguingly, the signal was detected by only one of Big Ear's two feed horns. The telescope had twin receivers pointing at slightly different parts of the sky. If the signal had been continuous, both should have picked it up. This meant the transmission was intermittent. It was on when the first horn was listening, and off when the second horn passed through the same region 3 minutes later. Everything about this signal screamed artificial origin: the narrow bandwidth, less than 10 kilohertz, the perfect celestial source pattern, the protected frequency near the hydrogen line. It was exactly what SETI researchers had been hoping to find for decades. There was just one problem: they never heard it again. The response was immediate. The Big Ear team returned their telescope to the exact same coordinates the very next day. Nothing. They tried for a month. Silence. A year later, they tried again. Still nothing. Word spread through the scientific community. Those coordinates in Sagittarius became what one researcher called probably the most widely observed of any in the sky. The Very Large Array in New Mexico turned its massive dish array toward the signal's origin. The Arecibo Observatory in Puerto Rico, then the world's largest radio telescope, joined the search. Facilities in Australia pointed their receivers skyward. For decades, they found nothing. But nobody searched harder than Robert Gray, a data analyst who became obsessed with finding the WOW signal. Gray spent his own money securing telescope time at facilities across the globe. Harvard's META experiment, radio telescopes in Australia, the Very Large Array. He even developed sophisticated models of stochastic beacons, signals that might repeat irregularly over months or years. His calculations showed a 33% chance that Big Ear could have detected such a beacon during its brief observation. But when Gray factored in all the subsequent non-detections, the probability dropped to just 1.8%. Gray continued his quest until his death in December 2021, never finding the signal that had captured his imagination decades earlier. Modern SETI programs have capabilities that dwarf anything available in 1977. Breakthrough. LISTEN, launched in 2015 with $100 million in funding, uses telescopes 50 times more sensitive than Big Ear. They scan 10 times more sky and cover 5 times more radio spectrum. China's FAST telescope, the world's largest radio dish, has made SETI one of its core missions. Unlike earlier projects, FAST was designed from the ground up with extraterrestrial intelligence searches in mind. In 2022, both the Green Bank Telescope and Allen Telescope Array simultaneously targeted a candidate star system identified by researcher Alberto Caballero. They found nothing. Which brings us to the theories, because if it wasn't aliens, what was it? The explanations scientists have proposed range from the mundane to the exotic, and some of them are more convincing than others. In 2016, researcher Antonio Paris proposed that Comet 266P/Christensen caused the WOW signal. The comet was passing through the area at the time, and its hydrogen cloud could theoretically produce radio emissions. The original Big Ear team wasn't convinced. As Jerry Amon pointed out, a comet would create a diffuse, spread-out signal, not the sharp, intense burst they actually observed. Could it have been human-made interference? Satellites, TV stations, military transmissions? The problem is, that frequency was internationally protected. No known satellites or broadcast stations operated in that band in 1977, and the signal's behavior, growing stronger, then weaker as Big Ear's beam passed over it, matched exactly what you'd expect from a celestial source. But the most recent explanation is also the most intriguing. In 2024, Abel Mendez and his team at the University of Puerto Rico proposed something fascinating. Using archived data from Arecibo, they detected similar but much weaker signals near the hydrogen line in 2020. Their hypothesis? The WOW signal was caused by a magnetar flare. Picture this. A magnetar, one of the most powerful magnetic objects in the universe, unleashes a massive burst of energy. This energy strikes an interstellar cloud of cold hydrogen, causing it to brighten suddenly through stimulated emission. Essentially, space itself became a giant laser. This theory explains everything: the frequency near the hydrogen line, the incredible intensity, the duration, and most importantly, why it never repeated. Magnetars weren't even theorized until 1992, 15 years after the signal's detection, which explains why this explanation wasn't considered earlier. But here's the thing about scientific explanations: they're only as good as the evidence supporting them. And while the magnetar hypothesis is compelling, it's still unproven. Which means, nearly 50 years later, we still don't know for certain what Jerry Eamon detected that August morning. The story of Big Ear itself has a tragic ending. Despite its historic achievements, including the longest-running SETI program ever, the telescope was demolished in 1998. Developers bought the land to expand a golf course and build homes. The instrument that listened to the cosmos for over 3 decades was reduced to scrap metal. Today, a small historical marker stands near the site. It's the only physical reminder of one of humanity's most important radio telescopes. But Signal's influence extends far beyond science. It's appeared in documentaries, inspired science fiction, and captured the public imagination in ways few scientific discoveries ever do. Netflix's adaptation of The Three-Body Problem uses it as humanity's first contact with alien civilization. Countless researchers have dedicated their careers to understanding those 72 seconds. Jerry Eamon himself remained remarkably cautious about the signal's origin. Even decades later, he chose his words carefully. "It certainly had the potential of being a signal from extraterrestrial intelligence," he said in 2016. Seth Shostak of the SETI Institute puts it more bluntly: "Nobody knows what it was." He compares it to hearing chains rattle once in an attic and never again. The search continues. Today's instruments are thousands of times more powerful than Big Ear. If a similar signal appeared now, it would trigger immediate, coordinated observations from telescopes around the world. Real-time analysis, global networks, the kind of follow-up that was impossible in 1977. So what should we make of the WOW signal? Maybe it was an exotic astrophysical phenomenon, a cosmic laser created by forces we barely understand. Maybe it was interference from a source we never identified. Or maybe, for exactly 72 seconds on August 15, 1977, we heard from someone else. The truth is, we may never know for certain. And perhaps that's what makes the WOW signal so fascinating. In an age where information is instant and mysteries are rare, here's something that has refused to reveal its secrets for nearly half a century. As we approach the 50th anniversary in 2027, the WOW signal remains what it's always been: a tantalizing glimpse of something extraordinary, a reminder that the universe can still surprise us. And sometimes, when faced with the unknown, all we can do is what Jerry Eamon did that morning in 1977. We can look at the evidence and say, wow,